हेलो स्टूडेंट्स, हाउ आर यू। होपफुली बेटा आप सब बहुत अच्छे होंगे। देखिए, अब हम एटॉमिक स्ट्रक्चर में ऑलमोस्ट लास्ट पोर्शन में एंटर कर रहे हैं। दिस पोर्शन इज़ वेरी वेरी क्रूशियल फॉर बोथ सब्जेक्टिव एज वेल एज ऑब्जेक्टिव. That means it is very useful for the competitions also in the IIT JEE mains and advanced both, as well as in the NEET, AIMS or some other competitive exams. बेटा ये जो लास्ट पोर्शन है दैट इज द वेव मैकेनिकल मॉडल एंड क्वांटम मैकेनिकल मॉडल ऑफ द एटम. इससे पहले जितने भी मॉडल डिस्कस्ड हुए, जितनी भी थ्योरीज डिस्कस्ड हुई, लाइक इलेक्ट्रोमैग्नेटिक वेव थ्योरी, जे थॉमसन मॉडल, रदरफोर्ड अल्फा स्कैटरिंग एक्सपेरिमेंट, प्लैंक्स क्वांटम थ्योरी, explanation of black body radiation, explanation of photoelectric effect, and Bohr's atomic model or Bohr's atomic theory, as well as explanation of line spectrum of hydrogen with the help of Bohr's atomic theory. Dear students, after the studying of Bohr's atomic model, scientists observed that there are also some limitations of this model, because Bohr's atomic model, it's a two-dimensional atomic model. According to Bohr, in any atom there is nucleus and electrons revolving around the circular orbits around the nucleus. However, these orbits have definite amount of energy, definite amount of angular momentum. That means orbits are fixed. However, these are the imaginary part. Orbits around the nucleus, that is the trajectory of revolving electrons around the nucleus, is fixed. Distance of the electron from the nucleus is also fixed. Angular momentum associated with the orbit is fixed. Energy associated with the orbit and electron is fixed. Bohr ने कुछ ऐसे कहा. However, Bohr atomic theory explained very well to the Rutherford's limitations, like stability of atom as well as line spectrum of hydrogen. However, it could not explain number of phenomena, theories present at that time. For example, Bohr's atomic model was true only for single electron species like hydrogen. Single electron species like hydrogen, or like species or ions which have only one electron, mono electron. That is, I am going to discuss introduction of wave mechanical model. In this model, first of all, you should know once again about the limitations of Bohr's atomic model. If you do not remember about Bohr's atomic model limitations, then we can't understand the concept of wave mechanical model. Dear students, limitations of Bohr's atomic model. It was the first explanation, limitation. Mathematically, Bohr's model explained only mono or single electron species. This model was true only for mono or single electron species like hydrogen atom, or like helium 2 plus, lithium 2 plus, helium plus, lithium 2 plus, and beryllium plus ions. These ions have only one electron. That means we can say, if we talk about the spectrum of the species or ions, in case of Bohr, it is applicable only for single electron species. That's why we can say this model could not explain multi-electron spectrum. According to this model, electrons around the nucleus, orbits may be number of infinite, but electron is the only one electron revolving around the nucleus. Single electron के लिए ही सही है, बाकी electrons के लिए सही नहीं है. अगर एक से ज़्यादा electrons हो, then Bohr atomic model is totally failed. It could not explain multi-electron spectrum. We have studied about the spectrum of hydrogen atom. We get large number of lines observed in the spectrum, that is observed by a spectroscope or by prism. We get large number of lines on the screen. And you remember, these lines are corresponding to the Lyman series, Balmer series, Paschen series, Brackett series, and Fund series. Latest one is the Humphrey series. These series emit radiations in the electromagnetic spectrum region, Lyman series in the ultraviolet region, Balmer series in the visible region, Paschen series and remaining all other series obtained belongs to infrared region. Okay. So another one, it could not explain fine line spectrum of hydrogen. Very useful term, fine line spectrum of hydrogen. हाइड्रोजन का आपने जो अब तक स्पेक्ट्रम पढ़ा, when electron jumps from any high energy level to low energy level, we get lines due to emission of radiation. When this emitted radiation is passed through the prism, we get number of lines. Okay, so what is fine line spectrum? I will discuss it later in detail. What is fine line spectrum? But remember, Bohr's atomic model was able to explain line spectrum of hydrogen, but could not explain fine line spectrum of hydrogen. What is this? Wait for 2 minutes. As well as it could not explain Zeeman and Stark effect. These are two new words, Zeeman and Stark effect. I am also going to discuss what are Zeeman and Stark effect, but remember, these terms cannot explain by Bohr's atomic model. It was the base of the development of new atomic model, that is the wave mechanical model. Another one, this model could not explain the distribution of electron in the orbit. You know, these are the orbits in which electron can revolve. But if there are more than one electrons in the orbit, if in the atom there are more than one electrons, what should be their energy order? In the orbit, if there are number of electrons, maybe 2 electrons, आपने पढ़ा होगा 9th 10th में कि किसी ऑर्बिट में 2n स्क्वायर इलेक्ट्रॉन हो सकते हैं, किसी भी ऑर्बिट में 2n स्क्वायर और इलेक्ट्रॉन्स हो सकते हैं. Maximum number of electrons present in any orbit is equal to 2n square. First orbit में 2 electron, n की वैल्यू ऑर्बिट नंबर. Second orbit में 8 electron. Now if there are 8 electrons in the second orbit, then how these 8 electrons are arranged within the orbit? Okay, are all these electrons have same energy? What is the distribution of energy of electrons within the orbit? It could not explain. This theory also could not explain why we take angular momentum of electron, angular momentum of an orbit in which electron is revolving as integral or a whole number multiple of h over 2 pi. Why we take angular momentum equal to h over 2 pi? What is h over 2 pi? H over 2 pi, h is the Planck constant, 2 pi is the revolution of one cycle, 2 pi angle, you know. It could not explain. As well as, dear students, this model could not explain the further development studied by number of scientists, like dual nature of de Broglie's concept. It could not explain Heisenberg uncertainty principle. However, you can say Bohr's atomic model was the just contradiction of Heisenberg uncertainty model. According to Bohr, electron can revolve only in those orbits which have definite angular momentum, and angular momentum is found to be integral multiple of h over 2 pi. According to Bohr, electrons can revolve only in those orbits whose energy is found to be constant. Definite amount of energy is quantized, fixed amount of energy. Momentum is fixed, energy is fixed, speed is also fixed in the particular orbit, distance of the orbit is also fixed from the nucleus. We derived some formulas in the Bohr's atomic model. But do you remember what is Heisenberg uncertainty principle? According to Heisenberg uncertainty principle, it is impossible to find out exact position, exact momentum of an electron revolving in the orbit both simultaneously. अगर आप किसी इलेक्ट्रॉन को जो न्यूक्लियस के अराउंड रिवॉल्व कर रहा है, इसकी एग्जैक्ट पोजीशन और इसकी एग्जैक्ट मोमेंटम दोनों एक साथ फाइंड कर ही नहीं सकते. It is according to Heisenberg uncertainty. That means according to Heisenberg, everything is uncertain about an electron within the atom. We can't predict any property with the certainty about an electron within the atom simultaneously along with some another property. So these are the limitations which leads to the development of new atomic model, that is known as wave mechanical model. So dear students, wave mechanical model basically based upon the theories and development came after the Bohr's atomic model, that is dual nature of de Broglie concept, that is the dual nature of particle, wave as well as particle nature of the electron, as well as Heisenberg uncertainty principle. So this concept is given by scientist Erwin Schrödinger. It was a German physicist, and he studied about the wave path traveled by an electron, because according to de Broglie, when electron is revolved around the nucleus, it has particle nature, no doubt, it has mass, but as well as it must also have 3D wave nature. That is, when electrons revolve around the nucleus, it should have wave nature. So let's see. Okay, these are the limitations. This is the introduction of wave mechanical model. Now I am going to discuss further what do you mean by finite spectrum and what do you mean by finite spectrum and Zeeman and Stark effect. Dear students, suppose this is the nucleus and these are the orbits according to Bohr, and suppose an electron revolving in this orbit. When electron jumps from high energy level to low energy level, then some radiation is emitted, because electron jumps from high energy level to low energy level, and when this radiation is passed to the present, we get lights. This is one transition from N2 to N1, we get one line. This is called line spectrum when we observed or studied by a spectroscope. But it is observed that when this line, ये जो एक single line है, you observe the line from one energy level to another energy level. This is the line. When this line is studied, observed by high resolving power spectroscope. Resolving means distinguish. आपने देखा होगा जब कभी आप मोबाइल खरीदते हो, आप पूछते हो कैमरा इसका कितने पिक्सल का है, कितने मेगापिक्सल का है. जो कैमरा जितने ज़्यादा मेगापिक्सल का होता है, इट हैज़ उसकी उतनी ही ज़्यादा रिजॉल्विंग पावर होती है, डिस्टिंग्विशिंग पावर. If two objects are near with each other, then how can you distinguish by just observing? So this is the line spectrum. When this one is observed by highly resolving power spectroscope. The spectroscope gives the spectrum, but उसकी जो resolving power है, we can distinguish कि इसके अंदर भी क्या क्या है. And it is observed that this single line, when we studied by high resolving power spectroscope, this single line is also composed by number of lines. One line, it is composed by number of lines called fine line spectrum. These number of lines are corresponding to the radiations have almost similar wavelength or frequencies. इसका मतलब क्या हुआ कि जब कोई इलेक्ट्रॉन इधर से इधर आया है, हाई टू लो एनर्जी लेवल में आया, तो वहाँ एक लाइन नहीं है, वहाँ बहुत सारी लाइंस हैं. और अगर वहाँ बहुत सारी लाइंस हैं, इसका मतलब ये है कि ऑर्बिट्स भी सिंगल नहीं है. जो ऑर्बिट्स जिनको हम एनर्जी लेवल्स बोलते हैं, इनमें भी कुछ ना कुछ है. मतलब ऑर्बिट्स के अंदर भी कोई एनर्जी डिफरेंस है, पोर्शन है. जो ऑर्बिट को भी अगर हम रिजॉल्व करें, तो वहाँ पे भी ऑर्बिट के अंदर भी कुछ चीज़ें हैं जिसमें इलेक्ट्रॉन कहीं पे भी हो सकता है और कहीं से कहीं भी आ सकता है, जिसे हम बहुत हाई रिजॉल्विंग पावर से ही समझ सकते हैं. सो दिस इज कॉल्ड फाइन लाइन स्पेक्ट्रम ऑफ हाइड्रोजन. दिस इज द डेफिनेशन. Using high resolving power spectroscope, it is noted that each line in the corresponding hydrogen spectrum is found to be composed of several number of lines nearly of same wavelength. This concept exactly fell to the Bohr's atomic model. बोहर ने ऑर्बिट को कहा दिस इज द सिंगल वन, यहाँ पे जो इलेक्ट्रॉन्स होंगे उन सबकी एनर्जी सेम होगी. बट अगर एनर्जी सभी की सेम है, यहाँ पे ऑर्बिट में इलेक्ट्रॉन है और उसकी एनर्जी सेम है, ऑर्बिट में कोई इलेक्ट्रॉन है, तो ऑर्बिट के अंदर यहाँ पे कॉन्सेप्ट जो निकला, दैट इज द ऑर्बिट एज अ मेन एनर्जी लेवल आल्सो हैव सम सब एनर्जी लेवल्स विद इन द ऑर्बिट. दैट इज द कॉन्सेप्ट ऑफ सब शेल्स. ओके, now this study further expanded, and what is the Zeeman and Stark effect? It is also observed that when these lines, line spectrum observed, these lines or line spectrum is studied under the electric or magnetic field. अगर आप इसको electric और magnetic field में रखते हो lines को, then this line is split into number of lines. Start splitting in the number of lines. So when spectrum observed undergo study in presence of external electric field, the splitting of spectral lines, the splitting of spectral lines is known as Stark effect. In the electric field it is a Stark effect, and the same splitting it's a splitting of spectral lines in presence of magnetic field is known as Zeeman effect. These type of phenomena also could not explain by Bohr. Okay, so these are the limitations of Bohr's atomic model, which was the further leads to the development for the next atomic model, that is the wave mechanical model. So dear students, in the next video I am going to discuss what is wave mechanical model or quantum mechanical model. Okay, so watch this video and understand the concept. यहाँ से आपको एक बात समझ में आ गई कि ऑर्बिट के अंदर भी कुछ है जिसको सबशेल्स का, मैं अब इसके आगे बताऊंगा आपको. सोमरफील्ड्स extension of Bohr atomic model, however it was removed from the syllabus, but what is the introduction of Sommerfeld atomic model, और इन सब से मिलकर के then we will discuss last atomic model, almost wave mechanical model. Okay, dear students, watch this video and take reference from the book, and if you have any doubt then please call me or message me. Thank you, thanks a lot.